Hi, forensic students. Welcome back. Hey, today's lesson is going to actually span over the next 2 weeks because we're near the end of our marking quarter. So let's use this lesson over 2 weeks and also use any additional time that you find that you have to get caught up on any back work. So this week we are going to introduce dactylography, which is really just the study of fingerprints. I've got a brief little PowerPoint here that I'm going to walk through. The PowerPoint's much longer than what I'm going to cover this week, which also spans into next week. We're just going to go through, I think it was the first 21 or 22 slides. So again, dactylography, this is the scientific study of fingerprints. If you want to fill in your guided notes now while I go through it, you can, or you can go back, rewatch the video, or go through the PowerPoint on your own. They will both be attached on my class page. So it looks like a fingerprint. This is an individual characteristic. We find it on our hands, on the tips of the fingerprints, but there are also prints on the palm of our hand. We also find them on our feet. So it's not just a fingerprint, but it's really a print. No two fingers have yet been found to possess identical ridge characteristics. So what this does is it allows investigators to use fingerprints as individual evidence. If your fingerprint is left at a crime scene, that means without a reasonable doubt, you had to, or at least your finger had to have been at that crime scene. There are upwards of 150 individual characteristics on each one of your fingerprints. So if a full fingerprint is left at a crime scene, they're going to be able to pull out upwards of 150 unique things about that print. Theoretical calculations are always the same. The probability is extremely small that two fingerprint patterns would be identical. In fact, the odds are 1 in 64 billion. So what is the fingerprint? Well, you can see there's a picture here with the 3 different types of print, which we will dive into in 2 weeks. We'll dive into, but those are called arches, whorls, and loops. But what exactly causes the print? That's the focus of the next little bit of this lesson. They are friction skin ridges found on the palm side of the fingers and the thumb. Friction skin ridges. Well, you guys know what friction is. Friction is a force between 2 objects that are rubbing together. If we didn't have fingerprints, our hands wouldn't have as much grip to them. So they provide us with a firmer grip when we grab things like a piece of paper or when we pick up a glass. It's the shape and the form of those skin ridges that you would see as black lines on an inked fingerprint. How are fingerprints formed? Well, this picture here should be some kind of a little clue. Your fingerprints formed long before you were actually born. In fact, they formed in the 3rd month of fetal development. There was a chemical reaction between the amniotic fluid that the fetus is floating around in and the developing skin. So that amniotic fluid that's touching the cells of the developing skin are going to create these little ridges and valleys in that developing skin. So the shape and boundary between your epidermis and the dermis will determine the form and pattern of the fingerprint. So thinking back to when you took biology a few years ago, your dermis is the layer underneath the top layer, and the top layer is your epidermis. Those 2 layers, sandwiched in between them, is this series of ridges and valleys. And those ridges and valleys lock the dermis and epidermis together. Otherwise, if you pushed your hands together and you slid them apart, the dermis and epidermis would peel apart. Kind of gross. But that interlocking of this layer that's called the dermal papillae, and you can see it in the slide here. They've kind of peeled the epidermis off, and you can see where the dermal layer's down here, and the epidermis, they zipper together with this dermal papillae. Those dermal papillae push up through the skin, and this is what's giving us our fingerprint. There's a little 1-minute video. The guy is not really exciting to listen to, but you can suck it up here and just kind of get through this 1-minute video where the guy is describing that dermal papillae layer. We've got 3 types of prints. I don't mean the loops, whorls, and arches, but instead there's 3 different ways that prints can be left behind. The first one here is called a latent or an invisible print. You're looking at this finger here, and you can see those little ridges sticking up. Do you see those tiny little openings on the tops of the ridge? That's actually where sweat and oil comes out of your skin. That sweat and oil is always sitting on the surface of your skin, kind of gross. And when you touch something, you leave that oil and that sweat, the salts from the sweat, behind as a latent or invisible print. So how do we see that print? Well, you have to dust it. So to go back to the text here, each skin ridge has sweat pores on it. The sweat, water, and alcohol comes out of the openings, deposits on the skin. The sweat mixes with oils, and when you touch something, that's what's left behind as a latent or an invisible print. So investigators have to make that print visible by dusting. And if we were in class, I've got black dust, I've got orange dust, I've got magnetic dust, I've got fluorescent dust. But at home, in 2 weeks, I'll be giving you a lab that'll tell you how you can kind of make your own dust just out of pencil graphite. And you'll be able to hopefully see your print. The next one would be a visible print that you might leave behind. So a visible print must mean that there's something on your hand and then you touched things and you left that behind. This one looks like it could possibly be blood. So it's made by a finger touching a surface after it's been in contact with a colored substance like blood, paint, grease. You're walking down the stairs and you touch the railing that's just been painted, and then you touch a light switch or the wall. You're going to leave that visible print behind. And our third type that we're talking about today is a plastic print. This looks like a glob of silly putty, and the person touched it and they actually left an imprint, an impression of their fingerprint. This could happen if, say, you touched something like soap that was a little bit sticky, or paint that was almost dry, or if you've ever put on nail polish and then you go to touch it to see if it's dried. If it's not fully dried, you'll leave your print in there. So those are our 3 types of print that we were talking about this week. Our latent, which means invisible, our visible, or our plastic prints. Investigators are going to be searching a crime scene for those. Let's talk about a couple famous prints here. We had the Hale crime family. Look at this picture. Can you see any fingerprints on the tips of their fingers? So genetically, some of these family members, they had no fingerprints. That means that that dermal papillae layer was not fully developed. So it was a genetic anomaly that just happened in their family. Is that why they turned to a life of crime? Who knows? Another famous case was this guy, John Dillinger. He attempted to destroy his prints with acid. He actually had tried to have plastic surgery initially to alter his face, but in that time, and you'll read about a case this week or next week, he had plastic surgery, and at that time, plastic surgery was not, it was kind of crude and rudimentary. It was a very painful procedure, and when they took all of the bandages off of his face, it hadn't really changed his look very much. So he was irate. So the doctor, in an attempt to to save his own life, he suggested that they try and alter his prints. So read about that and see how they tried to alter his prints. Turns out when he was caught, they shot him dead. In the morgue, when they took a look at his prints, his true prints were still pushing up through. This guy, this was crazy, Roscoe Pitts. He actually tried a skin graft, tried to graft skin from his chest over his fingers. So they cut all of his fingertips off, not like the whole finger, but they cut where the fingerprint was, peeled that off. And then they tried to do a skin graft by having him hold his hand against chest skin that did not show any kind of a print. I'm trying to remember, he had to keep his fingers, something like 6 weeks he had to keep it on there. When they took the fingers off, they found that upwards of 6 months later, his original prints still pushed up through. They hadn't gotten all the way through that dermal papillae layer. They say it's very painful. Here's another case that I want you to take a look at over the next 2 weeks. Taking a look at this picture. Is this the same guy? Look closely. In fact, you can even pause my video and look. Is this the same guy? What are some of the differences that you see? I'm going to put a discussion question up on my class page, and I want you to list any differences that you notice between these two. And I'm not talking about like the color of his jacket or his shirt is off a little bit. I'm talking about his physical facial features. Is this the same guy? So I want you to read about this case while you're running this slideshow, which is also on my class page. When you're running the slideshow, I want you to click and read about the William West, Will West case. In this case, before fingerprints were ever used to identify people, they used to use something called Bertillon measurements. And Bertillon measurements were, it was a series of measurements. I don't remember how many, it was something like 30 something measurements. They would measure like the length of your nose, the length of your chin, the width of your cheek. They would measure all the way around your head. They would measure the side profile from your nose to the back of your head. They would actually do some measurements on your arms, your legs, different fingers and toes, your jawbone, width of your forehead. These were the Bertillon measurements, and you're going to do a lab this week or next, whenever you choose to do it. And you're going to try and take your own Bertillon measurements. Read about the case, but what you're going to find is that this guy, Will West, was brought in and they did his Bertillon measurements. And his Bertillon measurements, the gentleman or the officer that was doing the Bertillon measurements, he said, "Have you ever been here before?" And Will West was like, "No, I've never been here." He's like, "I'm sure you have." And he went to his records, and sure enough, he pulled out a file for William West. Except it said that William West was currently an inmate there. And when they went and found William West, sure enough, he was an inmate there. And they stood him right next to this guy, Will West. Now, this was crazy. Similar name. These two guys look almost identical, and their Bertillon measurements were nearly identical. So they had to go to the next thing, which was the use of fingerprints. And when they fingerprinted William and Will, they found that their fingerprints were completely different. Absolutely crazy case. But this pivotal case let investigators know that they had to use fingerprints to identify people. They could no longer use Bertillon measurements. So we are going to save the 3 basic types of prints, loops, swirls, and arches, for 2 weeks from now. So instead, this week, you're going to read about these cases. You're going to answer a discussion question. You're going to do a lab on Bertillon measurements, and you're going to get caught up on any back work. So before the 10 weeks is over, we can get everybody up to nice high grade in forensics. All right. Stop into my office hours if you have any questions. We'll see ya.